So we want to carry on with this 91167 standard, and what we did last time looked at the importance of recognizing ions, because if you know how to split a compound up into its ions, then it's much easier for you to decide which part of the compound is reacting, is gaining or losing electrons, and which is just sitting around being what we call a spectator ion. So the way we're also going to find out if something has lost or gained electrons is using the oxidation numbers. So remember what I said last time, the oxidation numbers, they're theoretical numbers. So please don't think if I say carbon has an oxidation number of +6 that it has a +6 charge sitting on it. It's just a theoretical number just to help us work out if it's sort of got more electrons closer to it or if it has really lost more than its fair share of the electrons. So remember, there were the 6 rules you have to learn. The first one is if you have an element by itself, it is 0. So can somebody give me an example of a free element? Magnesium. Okay, so if I have magnesium metal, not magnesium ions, magnesium metal. The symbol is given as Mg, so that would be an example of a free element. Oxygen gas, hydrogen gas, fluorine gas, helium, any of that can exist by itself and is bonded to itself, then is a free element, and the oxidation number is 0. The next one is oxygen, if it's in a compound, will be -2. So if it's got H2O or copper oxide or any compound you can think of that has oxygen, it will always be -2, except for one exception. And there's only one exception you have to learn. Which one is that? So for level 2, there's only one exception you have to learn, and I'm sort of pointing at it, but you only have to learn one special case. So the special case is hydrogen peroxide, which is H2O2, and then it's -1. So that's the only exception you have to learn. Rule number 3, hydrogen. If it's not just by itself like H2, and if it's in a compound like H2O or HF or CH4, then it is always +1. And you don't learn the exceptions. I did say exceptions are metal hydrides, but at level 2, you don't come across those. So whenever you have hydrogen in a compound, it's +1. Next rule is if you have a simple ion, and this is why you need to recognize a simple ion. So if I say copper sulfate, you should know that sulfate is SO42-, so copper is Cu2+. Okay, if I gave it to you, CuSO4. So you should know that copper as an ion is Cu2+, and so because Cu2+ only contains copper in it and no other element, it's a simple ion. So the oxidation number of copper in Cu2+ is the same as its charge, +2. Okay. If I have sulfate, SO42-, can I say the oxidation number of sulfur is 2-? In other words, is sulfate a simple ion? No. It's got sulfur and oxygen in it, so it's not simple. It's got 2 elements in it. So a simple ion is when it's only got that element in it. A polyatomic ion is when it's got different elements in it. Okay. Or actually even more of its own kind. But again, you won't come across that at level 2 or level 3 actually. Right. Then if we've got something like copper sulfate and we want to work out the oxidation number of sulfur, then we say if I have a neutral compound, then the sum, if I add up all the oxidation numbers for every atom in that compound, the sum will equal to 0 because copper sulfate is neutral. And so when you're trying to work out oxidation numbers, this is a good one, a rule to use. So NH3, what is the oxidation number for nitrogen in NH3, you'd have to apply this rule. NH3 is neutral, so the sum of the nitrogen oxidation number plus the 3 hydrogens, which according to rule 3 is plus 1, has to equal to 0. Then the final rule you have to learn is what happens if it's not neutral? What happens if it's a polyatomic ion like sulfate, SO4 2-? How can I work out the oxidation number for sulfur and sulfate? And that's when you say, right, if I add up all the oxidation numbers, then it's going to be this, the sum will be the same as the charge. And for sulfate, it'll be -2. So that's quite a lot of talking. It's a lot of rules, but this is one of those things you just simply have to learn off by heart. So let's apply those rules. What is the oxidation number of chlorine in chlorine gas? 0. Okay, because rule number 1, a free element, I've got no other element in there, only Cl, so it has to be 0. Okay, what about chlorine in hydrogen chloride? -1, and that's where we apply rule number 5. It's a neutral compound, so you add it all up to be equal to 0. Rule number 3, hydrogen in a compound is always +1, and there's no exceptions as far as you're concerned. So there's my hydrogen, so X for my unknown. If I work it out, take the +1 to the other side, it becomes -1. Now do you notice how I've written this out? I've said the oxidation number of chlorine, or Cl, the element, in the species HCl is -1. Students often make sort of round things off very quickly, and they'll say, you know, they'll just work it out like this, but we need more information, and then they may say the oxidation number is -1, and I'll go, oxidation number of what? Okay, in what? So in this case, I've told you it's the underlined, and I've only given you one species, but when you do the task, you've got a number of species, so you've got to be very specific. Number 3, what is the oxidation number of oxygen? -2, correct, and that is a straightforward rule number 2. Oxygen in a compound is -2, and it's not hydrogen peroxide, so we don't have the exception. Or you could work it out using rule number 3, hydrogen in a compound is +1, and rule 5, that the sum is equal to 0. Okay, let's do hydrogen. Declan's onto it. What is the oxidation number for hydrogen? Okay, Declan, is this hydrogen in a compound? No. A non-good, it's 0, because this is rule number 1, a free element. Hydrogen is not bonded to anything else. So when it's the same thing like you got chlorine, you got the hydrogen. If it's not bonded to another element, it's a free element, and so it's and it's neutral. Okay, rule number 1 only applies to neutral free elements, so and it's neutral, so it's going to be 0. Iron, what will its oxidation number be? And that'll also be 0, because iron is only bonded to other iron atoms, so it's neutral. Okay, free element. It's neutral and its oxidation number is 0. What about iron in iron chloride? It's +2. Now there's different ways you could work this one out. You could say, okay, X for unknown. So using rule 5, the sum must all be equal to 0. Chlorine is actually chloride, so rule number 4 is saying a simple iron chloride is the same as its charge. So chloride has a charge of -1, so its oxidation number is -1. I have 2 chlorides and solve for X, and we get +2. Or you could just simply recognize, if I've got FeCl2, my Fe ion here is the Fe2 plus ion. And so just apply rule number 4 straight away. Are you following what I'm, so far how I'm working these out and when I refer to the ions? Is this all making sense? Okay. Then finally, what about manganese and potassium permanganate? +7, correct. And this is, if you didn't know it, by the time you finish this book, you should know it because it comes up so often. Potassium, it's in group 1, so if it forms an ion, it'll form the +1 ion. So rule number 4, a simple ion is the same as its charge. Potassium will always form the +1 ion. X is our unknown, manganese. I've got 4 oxygens. Now rule number 2, oxygen in a compound is -2. So if I solve this, I've got +1 plus X minus 8 is equal to 0. That's from rule number 5. So solving for X, you should get +7. Okay, notice I've said the oxidation number of manganese in the species potassium permanganate is +7. Right, so let's look at these very quickly. Here's copper sulfate. What is the oxidation number of sulfur in copper sulfate? Okay, not too sure? Copper, as I say, here you need to know your ions, and this is the big jump between level 1 and level 2 because you expect it to know the ions. There will also be given ions in a way at the back. So if you weren't sure was it SO4 or what, you could look in the back of the task. But you should recognize that SO4 is sulfate and it has a charge of -2, so copper must be +2, so that's where I get that from. X is the unknown sulfur, 4 oxygens, solve for it, and I should get the oxidation number of sulfur being 6. Chromate, so that's sulfate, this is chromate. It's also +6, and I think you can sort of see if SO4, 2 minus is +6, then for the oxidation number of sulfur, then the chromate should be the same. So you can see it's pretty much the same equation, except I didn't say copper chromate, so it's just chromate by itself. So I've applied rule number 6 where I've added them all up to get -2. Okay. Thiosulfate. So sulfate, okay, thio simply means I've taken an oxygen and replaced it with sulfur. So can you see the 4 oxygens have gone down to 3 and the sulfur has gone up because I've taken one of those oxygens and converted it to sulfur, so thiosulfate. What would its oxidation number be? +4? Well, it's actually +2 because I have got 2 sulfurs in it. So 2x plus 3 times -2. The 3 is, I've got 3 oxygens, so the -2 there is for the oxygen. And my charge is the total sum, which is -2. So if I work it out, 2x then is equal to 6 minus 2, which is 4. And so x is equal to 4 divided by 2, so it's +2. Do you all follow why I divided by 2? You're welcome to say no, because somebody else may be hoping desperately that somebody will say no. Okay, right, so you all follow. It's because I've got the 2 sulfurs, so I have to divide by 2. So the oxidation number of sulfur in thiosulfate is +2. Nitrogen in ammonia, -3, correct. Because hydrogen, remember, is always +1 in a compound, so N must be -3. And the same thing goes here. Okay, even though this is ammonium, now remember it has to be +1, and it still works out that the oxidation number is -3. How about sodium hypochlorite? What is the oxidation number of chlorine in sodium hypochlorite? Well done, Declan, you're onto it. So remember, sodium, group 1. So it can only form the +1 ion. Can't do anything else. So remember, potassium, lithium, sodium are all in group 1. They'll form +1 ions. So that's where that 1 comes from. X is my unknown. Remember, rule number 2, oxygen in any compound is -2 unless it's a peroxide. And it's neutral overall, so it's got to be equal to 0. And then if you solve for x, you should get x is equal to +1. And lastly, carbon in carbonate. Okay, that was super quick. You were waiting for it. So magnesium. Magnesium is in which group? Two. Correct. So when I say which group, I am always referring to the periodic table. And you are always given a periodic table in the exams, in the assessment tasks, and so on. So group 2 elements also form a +2 ion, just like things in group 1 form a +1 ion. So that's where that +2 comes from. X is my carbon that I don't know. Rule number 2, oxygen in a compound is always -2 unless it's hydrogen peroxide, and it isn't in this case. And rule number 5, it's all got to equal to 0. So you just solve for x and you should get +4. So do you think you can work out oxidation numbers? Because it is a vital part to pass the task. Correct. Great. Now, sometimes when you want to work out if something's going to lose electrons and gain electrons, just having a feel for the chemistry puts you on a good start. So, for instance, if you worked out that hydrogen had an oxidation number of, say, +4, do you think that that would be correct? No, because oxygen only had 1 electron to start off with. So how it could lose 4 electrons is impossible. Okay, so it's good to think of where the element is in the periodic table and think of how many electrons must it lose to get a full energy level, or how many electrons can it gain to get a full energy level. So hydrogen can either be 0 if it's a free element like H2. When I say 0, I mean the oxidation number. Or if it lost that electron, which it is most likely to do, it goes +1. So the hydrogen ion or hydrogen in a compound, because most things are more for non-metals are more electronegative than it. You do get hydrides, but you don't have to worry about them. This is when it combines with a metal. And you first come across a hydride at level 3 in organic chemistry. So what I'm trying to say is the possible oxidation numbers for hydrogen is +1, 0, or -1. And as far as you're concerned, you only need to know about those two over there. Okay, so if you work out +4, you know you've made a mistake. Oxygen. Now oxygen is a funny one in that it's very electronegative. So you won't go more positive than 0. The only one that will actually oxygen will give away some electrons to is to fluorine, because fluorine is the only thing that's more electronegative. Remember what I said about electronegative? It's the how strongly they attract the bonding electrons. So oxygen is very electronegative, so it'll always attract them the most strongly, unless it is bonded to fluorine, who just is a little bit stronger, and so fluorine will attract it closer to them. But you won't come across that compound, so as far as you're concerned, oxygen is either a free element, or it's -1 in the peroxide. Remember I said you've got to learn this exception. Or it's the ion, or oxygen in a compound. So it could be copper oxide, or it could be, that's where it's ionic, or it could be H2O, where it's just a theoretical number, but it's still gets given an oxidation number of -2. So that's like rule number 3 and rule number 2. So here's now the other ones, and if you get an idea, the metals are pretty easy, because the metals will really just lose electrons. You won't really get them gaining. So we're just going to really look at these non-metals over here. Okay? Fluorine is either naught or -1. It will never ever lose electrons to anything else. So fluorine will only gain electrons. It will never go more positive. So you'll never get +1 or +2 for fluorine. Oxygen we've already done. Nitrogen. Can you see that nitrogen could gain 3 electrons to get a full energy level? If I just sort of hop like 1, 2, 3, do you see what I mean? It's like I'm adding an extra electron, and now this means it's got a full energy level. Does that make sense? Yep, okay. And down here, lithium, of course, has got 1 electron. So to get a full energy level, if it's lost it, to sort of get back to there, I've got to get over here. So nitrogen can lose 1, 2, 3, 4, and then 5 electrons. So the highest possible oxidation number for nitrogen is +5. So if you've worked out +7, you've made a mistake, because it can't lose more than its 5 electrons. Carbon, the highest possible number is 4. 1, 2, 3, and then 4, because we're sort of back up there again. It's only got 4 electrons, it can only lose 4, or it could gain 4. So if I look over here, now here's for sulfur. Sulfur is either a free element, and the even ones tend to go in even numbers, the odd ones tend to go both odd and even. So sulfur is either 0, -2, +2, +4, or +6. You don't really get the others. Okay, not as far as you're concerned anyway. I thought I had other ones there as well, so let me just go back. Phosphorus, you could either gain 3 or you'd lose 5, just like the nitrogen. So any questions on how to use the periodic table, just to check whether your oxidation number is feasible? In other words, does it sound reasonable, or have you come up with a ridiculous answer? Do you think you could use the periodic table? Yep, okay. I have done a section in the 2071 booklet where I've done more elements and given you examples of it if you needed more feedback. Okay, now if the oxidation number becomes more positive, I don't really like this word increases or decreases, because it depends what you mean by increase and decrease. So if it becomes more positive, we have lost electrons, because remember, electrons are negative. So if I lose a negative, I become more positive. So sulfur dioxide, the oxidation number of sulfur in sulfur dioxide is +4, whereas the oxidation number of sulfur in sulfate is +6. So it's become more positive. How many electrons have I lost? Are you sure? Oh, okay. I haven't phrased that question properly. How many have I lost to go from SO2 to SO4 2-? So, sorry, Shania, I wasn't very clear. So say I had SO2, I'm bubbling this clear, colorless gas in here of SO2, and it becomes SO4. So I'm changing, my sulfur is changing in the SO2 to become SO4. So how many electrons has the sulfur lost in the SO2? Or we really refer to the whole thing SO2. 2. Okay, because it's changed from 4 to 6. So it's lost 2. Whereas dichromate, if we worked out its oxidation number for chromium, oxygen, of course, will be -2 because it's in a compound. So for chromium, it's +6 if you worked it out. But rule number 4, in the chromium 3+ ion, it's +3. So it's become less positive. And if it's less positive, the species has gained electrons. So can you see dichromate has, each chromium in the dichromate has gained 3 electrons. Because remember, I've got 2 chromiums in dichromate, and each one of them has gained 3 electrons. So you either say dichromate has gained 6 electrons, or each chromium in dichromate has gained 3 electrons. Does that make sense? Yep. Okay. So let's, because I see the time always flies. If we use the oxidation numbers to see whether the substance, bromine, permanganate, hydrogen peroxide, etc., has it lost or gained electrons? So what you do is you work out the oxidation number of each. So it's from 0 to -1. I have become more negative. So my bromine has gained electrons. Permanganate will actually always gain. It can never lose because it can't go more positive than what it already is, because it goes from +7, if you worked it out, to +2. So it's gained 5 electrons. There, each bromine atom has gained 1 electron, or one bromine molecule has gained 2 electrons. Hydrogen peroxide, each oxygen has gone from -1 to -2. Sorry, not -2. O2, free element, so it's gone from -1 to 0, so it's lost. So again, each oxygen has lost 1 electron, or you could say each hydrogen peroxide has lost 2 electrons, because I have 2 oxygens in hydrogen peroxide. Iodate to iodide, it's actually +5 there, going to -1. So it's gained a lot of electrons. It'll have gained 6 electrons to go from +5 all the way through to -1. Iodide to iodine, that's fairly straightforward. Who would like to have a go? Has it gained or lost electrons? I've gone from it's lost, because I've gone from -1 to 0. So it's lost, and here I'm going from H2O, H2O2 to H2O. Has it gained or lost? It's gained, because it's gone from -1 in a peroxide to -2 oxygen in a compound. So now I've got to, which are the reactants and the reductants and the oxidants. Now, a reductant and an oxidant are always reactants, so they always have to be on the left-hand side of the equation, never on the right. Okay? A reductant makes the other one gain electrons by handing over its own electrons. So does a reductant gain or lose electrons itself? It loses. Okay? If I have to hand over to you, I'm the reductant, I'm making you gain. So Br2 is an oxidant because it's gained electrons. Okay? This one has gained, so it's also an oxidant. Here, if it's lost, it's had to hand over electrons, so it's the reductant because it's reduced something else. So this is an oxidant, it's lost, it's a reductant, and here hydrogen peroxide is the oxidant again. Okay. Now I just want to, I know we're pretty much on time now, so I just want to stress this point. So oxidation is the loss of electrons and reduction is gain, but this is now for the half equations. Can you see it's shin, it's a reaction. So if it ends in TION, oxidation reduction, it's a reaction. If it ends in ent, it's a reactant. Okay, so for reduction you can use this oil rig to help you remember. Oxidation is a loss of electrons. But remember, we're talking about the reaction. So if in the reaction it's showing a gain of electrons, it's a reduction. The reductant is the ent, not the shin. I hope that makes it sort of clearer. So that is the reactant that appears on the left-hand side of the reaction. Okay, so reactants are the oxidants and the reductants. So an oxidant is reduced, and that comes up in the reduction half reaction. A reductant is oxidized, and that comes up in the oxidation half reaction.